Hello everyone, I'm myself Subhajit. So in this tutorial, will discuss about the problems from the center of mass coordinate that we have developed. So the first problem is as follows. So where you have a block A and block B, and which is the block A and B is attached by spring of unstretchable length small l and spring constant k, and at an instant of instant of time you are giving a sudden hit to the block A, and then you need to find the velocity of the both the blocks just after just at any later time. So, and by the way, the both the block slide without friction on this track, so this track is frictionless. So we will see the problem is easier to tackle in the center of mass coordinate. So how? Let's see. So here you have the block B and block A that is attached via the spring, and this is the position vector of block B, and this is the position vector of block A with respect to origin. Let's say origin is O, this is the x direction, this is the y direction, and the motion is of course one dimensional. So now what is the center of mass coordinate of this two system? The center of mass coordinate is defined like R is just m, since both the block has mass small m, both the block is of identical masses m, so it is R capital R equals to just m RA plus m RB by m plus m. Here I am not writing the vector since the R vector, since the motion is one dimensional. So it is just half of RA plus RB. So let's say this is the position of center of mass, and this is located at a distance of R, that is half of RA plus RB. Now with respect to the center of mass coordinate, that is with respect to O dot is the O prime is the center of mass coordinate. With respect to that O prime, position vector of A is just RA prime. Similarly for B is just RB prime. Now it is clear that since RB prime is directed along the negative direction and RA prime is directed along the positive direction, we have minus RB prime. Let's take a vector notation here, since we are treating with now a vector. It is minus RB prime plus RB is just capital R. Similarly, RA prime plus R equals to RA. Fine. So what is, now question is what is RB prime? So RB prime is just RB minus R. So this is the RA prime. Similarly, that RA prime is just RA minus R. So now the instantaneous length of the spring after the heat is just the change of the coordinate of A and B, that is RA minus RB. So what is RA minus RB? You can see from these two equations that Ra minus Rb is same as Ra prime minus Rb prime, right? So the equilibrium length of the spring, that is the unstretchable length, is small l. So the departure from the spring from the equilibrium length is just Ra, let's say delta L, let's say is just Ra minus Rb minus L, right? This is the length afterwards and this is the length before. This is the length afterwards, this small l is the length before the stretch. So this is also similar as Ra prime minus Rb prime minus L. Fine. So for better understanding, let me again copy these pictures here. So what is the equation of motion of the block A? So the equation of motion is just m Ra double dot. By the way, all the motions here is with respect to cm coordinate, center of mass coordinate. So in this case, since the body A is moving along the positive direction, the spring force acting will be along the negative direction, and for block B, the spring force will be acting along this positive direction, right? So the equation of mass motion, that is m Ra double dot prime, that is the coordinate, that is the motion with respect to the center of mass, that is m Ra prime double dot, is that k times delta L, that is since this is along the negative direction, so it is just this. And what is m Rb double dot prime? It is just, since it is along positive direction, so it is k delta L, right? Now, so if we subtract these two equations, so the only way you can consider the two system as a one system here. It's just you can subtract these two equations. So since these equations are coupled, coupled, like m Ra dot is minus k Ra prime Rb prime minus L, m Rb dot equals to k Ra prime minus Rb prime minus L. So these two equations actually are coupled. So in order to decouple this, we can subtract these two equations, like then we will get m Ra prime double dot Rb dot prime equals to minus 2k Ra prime minus Rb prime minus L. So if you define the new coordinate to be your u, like Ra prime minus Rb prime, then this equation transform to m u double dot minus 2k u equals to Ra prime minus Rb prime minus L, let's say. Then u double dot is just Ra double dot Ra prime double dot minus Rb prime double dot, and since L is constant, so it is 0. So u is just u double prime is this thing. So mu double dot equals to minus 2k u, right? So mu double dot plus 2k u equals to 0. So you know this is the equation for simple harmonic motion. So the general solution is just u equals to a sin omega t plus b cos omega t, right? So I'm taking again this picture here. so u is this thing, u at time t. So the initial velocity, so the initial, so now we need to consider that when t equals to 0, that Ra minus Rb equals to L. So Ra minus Rb is similar as Ra prime minus Rb prime equals to L. That means Ra prime minus Rb prime minus L equals to 0. That means u at t equals to 0 is 0. Again, the initial velocity of Va is V0 and of Vb is 0. So that Va0 is V0 and Vb0 is 0. That means our, so if we okay, that is our second condition. That is, if you take u dot, now you will get Ra prime dot minus Rb prime dot, and since L is constant, so you can ignore that. Now that Ra prime minus Rb prime, that dot is similar as, since Ra minus Rb, Ra prime minus Rb prime equals to Ra minus Rb, so this is similar as Ra dot minus Rb dot, right? And at time 0, u naught 0 is Ra dot 0 minus Rb dot 0, that is Va0 minus Vb0. And what is Va0 is just V0 and Vb0 is 0, so it is just V0. So u naught at time 0 equals to V0 and u at time 0 equals to 0. These two initial conditions we have. If we apply these two conditions in this equation, we'll get what is u0 is 0, it is just then b, right? The sin omega t is 0 and cos omega t is 1. That means b is 0. That means u of t equals to a sin omega t. That's the thing. Now what is u naught t is just a omega cos omega t, right? And what is now u naught 0 is just a omega, since cos omega t is 1, and this is just v0. So a is v0 by omega. Oh, by the way, that omega is root over 2k by m, since this is equivalent to u double dot plus omega square u equals to 0, and that has the solution this. So what is our u of t now? U of t is v0 by omega sin omega t. So now what is Ra prime? Ra prime is Ra minus R and Rb prime is Rb minus R. Since R is half of R1 plus, half of Ra plus Rb, so then we have, so this one as Ra prime is just half of Ra minus Rb, and Rb prime is just minus half Ra minus Rb, right? So what is Ra prime dot, that is Va prime at later time, is half of Va minus Vb. Similarly, what is Vb prime is minus of half Va minus Vb. But we have just taken the time derivative with respect to this and this to get this relation. So that means that Va prime is minus Vb prime. Now that Va prime minus VB prime is just U dot, right? So this relation. So now since VA is minus VA prime is minus VB prime, that means that VA prime is minus VB prime is just the half of V naught, that U dot U expression U in terms of time we know. So if we plug this here, it is just half of U dot, right? And what is U dot? U dot is V naught omega by omega cos omega t. That means VA prime is minus VB prime is V naught, sorry, by factor of 2 is missing here, V naught by 2 cos omega t. So now the original coordinate, that is VA. So since the RA prime is just RA minus R and RB prime is RB minus R, so the original coordinate, that is RA, means this expression, sorry, yeah, so that means that RA means this laboratory coordinate, and this RB, the original coordinate, that's, let's say that RA is just RA prime plus R, RB is just RB prime plus R. That means VA is just R dot plus VA prime, and VB is just R dot plus VB prime. Now the question is how to calculate the R dot. So what is R? R is just sum over, so it is just, sorry, MA RA plus MB RB by MA plus MB. In our case, MA equals to MB equals to M. So what is R dot? R dot is nothing but MA VA plus MB VB by MA plus MB. So it is nothing but that PA, linear momentum, plus PB by MA plus MB. So it is the sum of the linear momentum. So we know our F total external is just sum over Pj, right? Sorry, sum over dpj by dt. So in our case, J is A and P. So sum over J means here if total external is just d by dt d by dt of PA plus PB. So since there is no external force in our system that consists of the block mass MA and mass MB, that means our F total external, that thing that is actually 0 in our case. So that's why that PA plus PB, that is constant. At an instant of time. So from here, that means that R prime at t is similar as R prime at 0. That is MA VA0 plus MB VB0 by MA plus MB. And what is BA0? BA0 is just V0, and what is VB0 is just 0, that is MA plus MB. since ma equals to mb, and that's why it is just v naught by 2. So that means our what is va. So for that we need to know va prime, and what is va prime. So what is va prime equals to v naught by 2 cos omega t, and what is vb prime equals to minus va prime, that we have already proved. It is minus v naught by 2 cos omega t, and that's why our va is r naught plus va prime. And what is vb? vb is just in the similar way, vb is just r naught plus vb prime, right? So this will be dot. Okay, this is just vb. Fine. So now va is just r naught plus va prime, that is v naught by 2 1 plus cos omega t, and what is vb? r naught a dot plus vb prime, that is v naught by 2 1 minus cos omega t. So these are our answers. So that means the masses moved with the half of the velocity, but whenever va is maximum, vb is minimum. That is clear from these expressions. And whenever whenever va is minimum, va is maximum. So the masses move to the right on the average, like they are moving with the velocity v naught by 2, but they alternatively come in rest whenever that these terms vanishes. Whenever this terms vanishes, this goes to maximum, and whenever this vanishes, this goes to maximum. So they alternatively come to the rest and push me and pull you fashion. So that's the motion of the masses. So that's all for today. Thanks for your attention.